Okay, this is block 1 from topic 1, using ratios. First thing we're going to talk about is what is a ratio. One person said a ratio is something that compares something. Did you say? A number compared to another number. Okay. And then we talked about what are some examples of ratios. And one person said it could be written with a colon, so like 1 to 5. And that could be objects like 1 football to 5 baseballs, or what else could 1 to 5 mean?
1 chocolate bar to every 5 packages of M&Ms.
1 chocolate bar to 5 packages of M&Ms.
1 volleyball for every 5 basketballs.
1 volleyball to every 5 basketballs. Did we talk about, is this the only way to write ratios? We can also use the word, somebody said the word to. How else could we write it? You could write it like a fraction, so 1 over 5. Do you have another way, or she took it? Okay. There's actually one more way, but we'll go over that. And how are ratios and rates related? Are they related? Raise your hand if you think ratios and rates are related to each other. Yes, you think they're related. Who thinks they're not related? Who has no earthly idea if they're related? Oh, goodness. Okay. Well, maybe we can answer that question here in a minute. So we are looking on our online textbook. And remember, you can always access this at home. Right now, it's not up right now, but it will be. And it says a ratio is association of 2 or more quantities. So, does it compare 2 things? It does. A ratio statement describes how the quantities are related. Ratios are very useful in everyday life. We talked about how to represent ratios already. So you are open in your book to page 1. And the first, if I get my sheet, I'll get my life together here. That's where I want to be. All right. So, looking at this first picture, if we're looking boys to girls, how many boys to girls? What's the ratio? You can shout it out.
2
to 3. There were 3 different ways they wrote this. Something we did not write earlier was the word for every. So for every is another way we can write this. So 2 boys for every 3 girls. Those are all ratios, written several different ways. So if I wanted to do, on question 1A, it says, what are the ratios of girls to boys in your class? Well, let's count how many girls we have. We have 1, 2, 3, 4, 5, 6. So we have 6 girls. How many boys? Anybody counted the boys already? 10 boys. 6 to 10 boys. Is that the only way I can write that?
No.
I could write it as
6, 2,
6. I could include the words. Oh gosh. 2 boys. I didn't include the number. 10 boys. I could write it as a fraction. 6 over 10. I could write 6 girls for every 10 boys, but I'm out of room, so I'm not. Okay, those are different ways I can represent the ratio of that picture.
Yes, sir. Does the big number always have to be second?
No, we're actually going to talk about that in just a moment. Okay? Good question, though. Lots of people want to do that, though. So that's a very good question. All right, let's go back to our picture here. We talked about that. Let's look at our marbles picture.
You okay?
All right. Here they have my stuff written in a table. What are they doing with this red writing on my table? What does that mean?
They're multiplying the top and the red line.
They're multiplying it times what?
2.
2. They used a dot for multiplication. We're 7th grade, and here on out, they're always going to use dots for multiplication. Okay, so they're multiplying both sides by 2. So I have 2 to 4 marbles, then 4 to 8. Are these equivalent? Did they go up by the same? Yes, they did. Okay? That's important to note. Let me regain my breath here. So on your 1B, you have a table. Fill in the rest of the table. Is everybody going to fill in the same numbers? There's a ton of different numbers we could pick here. We're probably not all going to write the same numbers. So come up with other ratios that would be equivalent to 2 to 4. 4 to 8 was one that's written already. Write 3 more that could be equivalent in the table. All right. Wyatt, what's one you wrote? A ratio you wrote in your table. That's not the right class. I was wondering why he wasn't looking at me. Brody, which one you got? Anyone, pick any. 6 to what? Is 6 to 8 one?
No.
6 to 12.
6 to 12 is one. Does the 6 to 12 reduce down to 2/4? Okay, what's another example? Jack? Jake?
8 to 16.
8 to 16. Is 8 to 16 one?
Yes.
Aubrey?
10 to 20.
10 to 20 is 10 to 21.
Yes.
Okay, what about 25 to 50?
Yes.
Yes.
What about 5 to 10?
Yes.
1 to 2?
Yes.
Okay. Could we have all written the same ones down?
Yes.
We could have, but did we? No, because there's a ton of them. Okay, but look at the question above your chart. It says the ratio of red to blue marbles. If a question said write the ratio of red to blue, and I wrote that as my answer, 2:4, is that the correct answer? Red to blue.
No.
Why?
Because the red marbles, there's 4 red marbles.
I said red first. So that would have to be recorded first. So back to your question. Jake, does the big number always get written first?
No.
Not always. It depends on the word that the question asks. So red to blue, we swap the order. If they ask blue to red, we swap the order again. All right, let's go. Oh, we are on the video. Let's go back to the image. Let's look at this little pizza guy. Throwing that, he's talented. That would land on my head. How are ratios related to cooking?
You have to know how many, like, how much of this ingredient and not the other ingredient.
So, like, every
Okay.
2 eggs, you need to have, like, 4 cups of sugar.
When you need 2 eggs.
I like it. Anything else? Yeah, good. So Hunter, I'll send this to your guardian and know that you're on recording, not paying attention. Okay. So yesterday I was sitting in the lunchroom and I looked over at someone else's lunch and it looked like it was an apple cobbler, but it was actually these weird potatoes. And I was like, oh man, I thought it was apple cobbler and that sounds delicious. And Miss Russell heard that, and today she brought in an apple cobbler. And she left it in the workroom for all of us. And she said, that's not the normal size apple cobbler that I normally make. I had to double my recipe so everybody could have some. When she doubled the recipe, how is that related to ratios? Because it's times 2. Did she multiply all her ingredients times 2? Or just some of them? All of them. If she only multiplied a couple of the ingredients times 2, it wouldn't taste good, right? Okay, so she had to multiply all of them times 2. So cooking is very useful with having ratios. So looking at our letter C in our workbook, it says for the ratio 2 cups of flour for 1 cup of water, write 2 associated rates. And we didn't know if ratios and rates were the same. Well, a rate brings something down to 1, like 50 miles per hour. For how many hours? 1 hour. So 50 miles per 1 hour is a rate because it brought it down to 1. Well, 100 miles per 2 hours, that's a ratio. What is its rate? What could I reduce that to? 50 miles per 1 hour. That's its rate because it was reduced down to 1 item. So a rate reduces down to 1 item. So it says 2 cups of flour to 1 cup of water. Or it's supposed to say of, it says or. Okay? Do I have something that's out of 1? What is it describing?
Water.
Cup of water. Okay? So that is actually an example of a rate already. So I'm just going to underline it so I don't have to rewrite it. That is one example of a rate because it's brought down to 1 item. But they said to write 2 examples. Well, what if I only had 1 cup of flour? How much water would I need? I have 1 cup of water. 1 cup of flour. How much water would be needed? Half a cup. So a half a cup of water to 1 cup of flour. Lead is a little large. Do I still have my 1? Yes, so it's a rate. Okay, we're going to use sticky notes on some pages, and that's going to be like our important stuff to help us remember stuff. So grab one sticky note, stick it on this page somewhere, and we're about to write on it. This is going to be our anchor chart. Anywhere on the page. You can cover it over that table or something. Sure. Okay, and on that anchor chart, write ratio at the top. We're going to recap what a ratio is. And what was a handy, dandy, easy definition that we can use to recap what a ratio is? What did it do? Comparing to, okay, or quantities, compares two or more. It can be more. Most of the time we just see two. So it compares two or more quantities. Yeah. Or a fancy word for amount, maybe. Or, yeah. What was some different ways that we wrote ratios? In a fraction. How else?
In a colon.
With colons. The word form, what was that word? For every, or there was also two. So jot those examples down. Those are some examples of ratios. Alright, we're going to go back to our book here. And we have already discussed this. We are going to go to page 2. Alright, so we have a chickadee here. Looks like she's going to do some work on her computer. And let's see what kind of work she's going to do on the computer. She has a picture. And it says original and enlargement. Is the enlargement enlarged actually right now? No, it's not actually enlarged. Well, I can use this little slider guy here on my little mouse. I slide it over to 2. What's going to happen? It gets larger. How did it get larger with the length? Okay. How did it get larger? You multiplied by 2. But if it multiplied the length by 2, what did it do to the width?
Multiplied by 2.
It multiplied it by 2 as well. Well, what's going to happen if I move to the 3? What's going to happen to the length and the width?
Multiplied by 3.
It's going to multiply by 3. And it gets larger. Then if I go to 4,
Multiplied by 4.
multiply both sides by 4. Okay? So as long as I am multiplying both sides by the same number, that is called proportional. The picture is staying proportional. Did I change the picture any? Did I crop it? Crop the hat out? Stretch it? Make it taller? Did I do any of that? So that means that the picture is proportional. I have several of these big pictures in small sizes. Did I change the picture any when I put it in the small frame? No, I just proportionally made it smaller, the length and the width. Alright. So let's go to this second one. What is she doing here?
She made three times smaller.
Made them smaller.
Oh no, not fourths. Wait, that'd be fourths.
3/4 smaller and then 1/4 total smaller. But did she do the length and the width by the same?
No. It is. Yes.
Yes. So did it change the picture any? Did it get cropped or anything?
No.
No, it stayed the same. That means it was proportional. When you're multiplying something by this same number on both sides of this table, that's called a scale factor. Scale factors keep things proportional. So that's important to note. Scale factors keep things proportional. If I multiplied the width by 2 and the length by 3, is the picture going to be proportional? Did I multiply by the same number? No, it's not going to be proportional. So we need to go to our number 2 and define what a scale factor is. Well, a scale factor is a number you can multiply the dimensions of a figure by to enlarge or reduce the figure without distortion. All right, let's go back. What's happening here?
She's stretching, she's talking, well, she's like stretching it.
So did she use the same scale factor?
No, she's well,
So that's not really a scale factor because she used two different numbers to multiply the width and the length. Well, on the first image, she stretched it long ways and it made herself look kind of fatter because she didn't keep it proportional. Then on this long one here, she stretched it long ways, made herself tall and skinny, and it did change the picture because she did not keep the length and width proportional, the same. All right, let's look at some paint. They're pouring in some blue paint, 4 cups. Then they're pouring some yellow paint, 4 cups. They find that the ratio is 1:1, and it results in that green color when stirred. How can I maintain that color of mixture while making different quantities? If I needed more paint in that color to finish painting my room, how could I maintain that paint color? Talk with the people at your table and see. I want another container of paint. How do I get it? Okay? Who thinks their group's got it? What's your group got? Half and half of, like half of what?
Half of not like this.
So you're pouring equal amounts of both paints is what you're trying to say? Okay. Is that what you're going with? Okay. All right. And it will result in the exact same color you're saying? No? You don't think so?
It will.
Okay. Because if I painted one wall this green color, and do I need the other wall to be off any? No. I have paint at my house that I took in, and the sample didn't come back matching. And you can tell where I went over. So let's watch this. Now they're pouring 4 cups blue, and they're pouring 8 cups yellow. That reduced to 1-to-2 ratio. Did it create the same green mixture? No. Would I want to use that paint? No. So, these are not equivalent ratios because they didn't reduce down. So I agree that you would have to have half and half or equal amounts in both. Okay? Moving on here. Here I have a vehicle, it looks like, and distance and time. Time's going up, distance is going up. Is that an example of a ratio?
Yes.
Yes, it could be an example of a ratio. Well, we already discussed recipes. Is recipes examples of ratios? Yes, because Miss Russell cooked, doubled her recipe. Here, they're quadrupling the recipe. So they need 4 sets of eggs. 2/3, they need 4 sets of that. 4 sets of 3/4. 4 sets of a half. And 4 sets of that whipping cream for that recipe. So they quadrupled it. If they forgot to quadruple one of those items, would it taste right? No, it would not. Okay, so look at your number 3 in your book on the back page. It says write down 4 situations that would use proportional reasoning. We've talked about several of them. We talked about lots of things. Write them down. We had pictures. Do you want pictures to be proportional sometimes? Yes. We talked about mixing paint. We talked about speed, miles per hour. We talked about, does anybody have anything new? We talked about boys to girls. Okay, I'm going to stop you there for time purposes. I want you to go to number 4. Number 4 is going to be homework and 5. And whatever is listed on your half sheet that you picked up, your half sheet tells you what your homework assignment is. The way homework assignment works on a Friday, I don't check homework on Friday till Tuesday. But you might have homework assigned on Monday too. So I check Mondays and Fridays on Tuesday. It tells you on the half sheet what numbers. What does it say for block 1 on the half sheet? Number 4 and 5?
4 and 6.
On the half sheet.
That's another.
Like 4 through 5. If you have a 4 through 6, you picked up the advanced class. Number 4, you're supposed to take a poll of the class. How many of you in here are left-handed? Anybody left-handed? So write, we're not done. Write 0 for left-handed. Write 20, open it up. Write 20 for right on your chart on number 4. 0 and 20. Number 5, you need to use your leap reference sheet to help you solve it. So you might want to write leap reference sheet. Number 5, where is your leap reference sheet? In your binder. Okay? And I will be checking that Tuesday.